Welcome to All This Math. This is Professor Parker, and today we're going to do a problem that was actually sent in by a student. This problem right here up on the board was sent in by Maniya from Philly. All right, so let's read the problem. It's a word problem. All right, and when we have word problems, what we should always do is read the problem carefully and try to think about what the important information is that you need to pull out so that you can solve the problem and answer the question. So if we read it, it says that Anaya hosted 2 dinner parties for her friends. All right. Another thing I like to recommend for students is to try to incorporate yourself into the word problem. So don't just let this problem be about some random girl, some fictitious girl named Anaya. Imagine Anaya is you, or imagine Anaya is somebody that you know, or imagine Anaya is your cousin, right? Because that makes the math seem less abstract. That makes it seem more real when you make it like, okay, like imagine this was me doing this, and this is a real life situation, right? It makes the math less intimidating. All right, so like I said, Anaya hosted 2 dinner parties for her friends, okay? 25 guests attended the first dinner party, and 29 guests attended the second dinner party. What is the percentage? Now, this is the important part, right? The most important part, I should say. What is the percent increase of the number of guests from the first party to the second party? So that's the actual question that's being asked. What is the percent increase? Okay, so there's a formula for percent change. Now, change could be an increase when the number goes up, or change could be a decrease when the number goes down, right? Just like with the temperature can go up from one day to the next, or the temperature can go down from one day to the next. Or the amount of money in your pocket, it can go up from one day to the next, or it can go down from one day to the next, right? So percent change could be increase or decrease. In this particular problem, we know that it's an increase because of the language from the word problem, and the word increase is right there. So we know it's an increase, but it could have just as easily been a decrease. In her first dinner party, there could have been 29 guests, and in the second dinner party, there could have been 25. 25 is less than 29, so that would have been a decrease. But anyway, this is the formula that you need to use. Anytime you're doing a problem dealing with percent increase or percent decrease, it's called percent change. So what you should do is definitely write this down on your paper, write this down in your notes. The percent change is equal to, and this is a fraction right here, right? In the numerator, you have new minus old divided by old, right? Now what that means is the new value minus the old value divided by the old value times 100. All right. Now, what does that mean, though? What does new mean? So if you're comparing 2 things, something happened first and something happened second. So the thing that happened first is going to be your old value. The thing that happened second, or which is more recently, that's your new value. So in this particular problem, and this is something else I want to point out too, we should always try to underline important information. So as we're reading through the problem, we know that, okay, 25, that's important. And 29, that's important. And we want to know what is the percent increase. That's important because that's actually what we're trying to figure out, right? So we know that that's important too, right? So that's our information that we're going to plug into the actual formula. So then we're going to do our new value. That's the amount of people that was at the second party, because that's the newer party. So it was think about it like this. It was an old party and a new party. The first party would be the old party. The second party would be the new party, because something happened first and something happened second. So it goes in order by the numbers. So your new amount, which is the second party, right? 29 guests attended the second party. So we're going to say 29 minus. And then the old value is how many people attended the first party, which is 25. So we replace the word new with the number 29. We replace the word old with the number 25. And it just so happens that in this formula, we have the word old again. So we're going to replace the word old with the same number, because old is old in this particular problem. It's still 25. And then we got this times 100. Now, this times 100 doesn't change. That's standard. That's just part of the formula. All right. So now we have all our numbers. And remember, like I said, make sure you have this formula in your notes. This is called the percent change formula, and this formula can be used whenever you're doing any problem that involves an increase or a decrease in percentage. And when you have to calculate what the increase in percentage was or the decrease in percentage was of anything. So now we just have to use some order of operations. And in this fraction, we can simplify this by doing 29 minus 25, which is 4. And then our denominator is 25. And then we got times 100. Now, it's a couple things we could do now. If we're using a calculator, you would just do 4 divided by 25. You would get a decimal, and then you just multiply that by 100. Or if you're not using a calculator, you might want to cross cancel, right? So if you're not using a calculator, you can cross cancel between these two fractions, right? Now, you might say, well, but 100 is not a fraction. That's true. But I can make 100 into a fraction. The same way you make any whole number into a fraction, you just write a 1 underneath of it. Any whole number can become a fraction by just giving it a denominator of 1. All right. And now what I can do is I can cross cancel because 125 have a greatest common factor of 25. So that means I can divide each of these numbers by 25. So 100 divided by 25 becomes 4, and 25 divided by 25 becomes 1, right? So now I just multiply straight across, and I do 4 times 4, which is 16, and then 1 times 1, which is 1. But I don't really need this 1 anymore, right? I don't really need it. So I can just do 16 divided by 1, and that gives me 16. So this is my final answer. So this means that there was a 16% increase from the first dinner party to the second dinner party. All right. So I hope that helped. And again, I can't stress enough. Put this formula into your notes. The percent change formula. The percentage change equals the new minus the old divided by old times 100. And that will give you the answer to any percent change question that you ever encounter when you have to find the percent change. Okay? Thank you for tuning in. Please like the video. Please subscribe to the page and tell some more people about the page. Have them subscribe to the page. And do remember always that there's all this math all around you.